So in this one, we're going to look at the Ancova, which is the analysis of covariance. And so again, I'm going to start up RStudio. I'm going to go down and find, well, actually I can't use the R commander for Ancova, so we have to, and I'll do this as slowly as I can, use code, which I know is not going to be fun for anybody. But the first thing that we need to do is we need to bring in the packages that we're going to be using. So we want to use car, we want to compute.es, compute effect sizes, we want to look for effects, we want ggplot2, multcomp, pastex, and WRS. Oh, well, we'll ignore that one. So the first thing that I need to do is I need to read our data into R. And so I'm going to name my data Timmy. And I do the less than sign and a minus sign. And then I'm going to do read.csv.file.choose. And then I do two parentheses within it. So it's Timmy, less than sign, minus, read.csv, file.choose, and then two parentheses. And then that will open up a window where I can go and get my data. And we're going to use the same data set, cami.csv. And what we're looking to do here is we are looking to, so now if I write Timmy, it lists our data set. So what we're looking to do here is we want to find out, is there a difference, if there was an initial difference in pretest scores based on their group, which means the college that they were in. If there were differences already, those differences might account for the fact that there were differences at post-test. So we want to control for the fact that we have differences at pre-test. So let's go ahead and we've already done the assumptions of the data, and so we're going to go ahead and so in order to make our model, we named the model, so I'm just going to name it model, and then less than, minus sign, AOV, which is an analysis of variance, parentheses, and then we are going to do, I'm going to look at my names up here, and post-cami is, it's case sensitive, so we're going to do post-cami, and then we do that little thing. And then we're going to do site, but I want to make sure that I have site is lowercase. So site, that thing 1. And then I'm going to do plus. So if I just did it like this, that would be a regular analysis of variance. But then I'm going to plus pre-cami data equals Timmy. So let me go through this again, or not date, data. So we have the model. So we've named the model, and we could do that any number of ways. We could name that anything that we wanted to. Less than, minus, AOV, analysis of variance, parentheses, and then what our post test would be, and then this sign, and then we go site 1, which is our factor, and then we are controlling for pre-cami, and then comma, the data equals what we named our data set, which was Timmy. So now we should be able to write summary model, which is the name that we named our model. And so at site 1, we have an F value of 7.214. This is a significant. Pre-cami was significant predictor. So if I want to find the adjusted means, which means that they were adjusted for that covariate, I would put in, and I'm just labeling this object. So when we do this, it's labeling something. So we're calling something object. And then I do effect. And then I'm going to do site 1. That should be that. So that should be in quotations. And then we have model. So then I believe I just called it model. SE equals true. Then we're going to do a summary of object. So we're doing a summary of what we named object. And we can see the effects. So the adjusted means are 145.91 set 3, 159, and 150. So these are slightly different than we saw at the beginning. Okay, so I had to redo everything. So I still have my model. I just did the analysis of variance, or the Ancova, with pre-cami as the predictor. So I'm going to go back and I'm going to just do all these things again. Summary.lm. I named it model. So again, we see that pre-cami was significant, and it significantly improved our model. So to do a post hoc test, I'm going to write post hoc. So I'm going to name it post hoc. GLHT model, because that's what we named our model. Then LIN FCT equals MCP, and this is site 1 equals Tukey. And we have a problem. I'm missing a package. So my problem was that I didn't have molt comps selected. So I'm going to go back up here and I'm going to grab this and copy it. I'm going to put it back down here. And we'll try that again. So that looked like it worked. So then I'm going to do summary of post hocs, or post hoc. And now we see that the Clemson-Anderson is still significant, but we didn't have significant findings on either of the other two. So this is the, so again we had, this is adjusting for the pretests. And if I wanted to, I could do an analysis of variance where I'm going to go model 2, AOV, and I'm going to do post cami. So this would just be a one-way analysis of variance, site _1, data equals Timmy. Summary of that model. And then to get to Tukey, so I'm going to name this post hoc dot Tukey. So we would use essentially the same thing that we did up here. So I'm going to go with GLHT model 2. Again, I'm just copying what I had up there, equals Tukey. But this is for model 2 instead of model 1. So then I write summary post hoc dot T. So now we can look at those means. So 17.153 here, we had 13.846 here. So you can see that those numbers adjusted for the pretest score. So all the numbers got a little bit lower to adjust for the pretest scores. But again, Clemson and Anderson were the significant one. And that's essentially it. So, you know, we run the analysis, we run the descriptive analyses that will tell us skewness and kurtosis. We do the homogeneity of variances. We do all of that stuff, and then we move into this part. And again, this part, it seems really complicated. The first thing that we did was we named our data set, and then we read in the CV file. Then we named our model. So this thing is the name. This AOV stands for analysis of variance, and then we do the dependent variable, and then we do this little thing, and then the factor variable, and then that would just be for a regular ANOVA, and then for an Ancova we would just add a plus symbol, and then what we're adjusting for, which is the pre-cami. And so then for the post hoc tests, we do the GLHT, we specify the name of the model, we type in this gibberish, and then our factor, and then the type of post hoc test that we're going to be using. I recommend that you go through and you go along with the video with R open in this data set to make sure that you're getting the same estimates and that you're able to do these things, because the assignment, or the test / assignment for this time will be to conduct these analyses on your own, and that's it.